So I'll be starting for all of you. Okay, the first thing first, I'll be starting with a recap of what machine learning is, but in a very abstract way. You've learned all of you have gone through the fundamentals of machine learning, the linear regression, the k-means clustering, and all of this. You've gone through it, but I'm going to summarize this as a benchmark platform from where you will see machine learning, and then on with the contrast of machine learning you will see deep learning. So the idea is that you have to understand what is the word deep in deep learning and why something has to go deeper. Okay, so in a mathematical sense we have to understand, otherwise this is not a theoretical subject. It's not history or economics or just some art subject that you can have your own opinion about it. There is no opinion, there is a structure. And all these mathematicians and computer scientists who worked on this have worked on a particular structure. We have to appreciate as engineers the structure which is making all of this happen. So once you're able to understand the structure, you will see the same structure people are struggling to implement it using technology. Okay, so technology will come every year. You have to upgrade with newer, but the newer technologies comes up, but to achieve the same ideology that I'm going to explain to you. Correct. So basically, it's like this: cutting onions have been we've been doing it from centuries, correct, for food. But as the technology moves ahead, if there's a mass onion to be cut, you will use machines for it. You have a slicer, a grater, something like that, right? Technology changes, you have to adapt to it, but ideology is still cutting onions only. So I have to understand the cutting onions part of machine learning and deep learning, which will never change because it's math. The fundamental is math. So let's work on that aspect. And just so that we can save on the bandwidth, I'll just turn off my camera. Okay, right. So now let's focus on the screen. Hmm. Machine learning recap. Basically, the machine has to learn, but the question is, what is it learning? In a fundamental way, first we have to understand the meaning of an algebraic function. The meaning of all of this is hidden in the algebraic function. Let's look at a simple function. Sum f of x, a function on x, is described as 2x plus 5. So 2x plus 5 is a function which involves x, a variable. So I said, given any variable, I want to multiply it by 2 and add a 5. So that's a function on x, and this is a particular function on x. Okay. Now I will say, let's take a set of numbers. Let us make this go through this function. Let's see what the resultant vector is. This is vector input vector. Okay, this is an input vector. This is my output vector which needs to be passed through this function. So go ahead and tell me what should come here subsequently. 2 goes into this. Ganeshri, tell me. 2 goes into this. 2 2s are 4, 4 plus 5. Yeah, am I audible?
Yes, sir, you are audible.
Tell me then. You only tell me the answer. 2 2s are 4, 4 plus 5.
9,
Okay. 5 2s are 10, 10 plus 5.
15,
6 2s are 12, 12 plus 5.
17.
70. So basically 2 became 9, 5 became 15, 6 became 17. This is what has happened, correct?
Yes, sir.
It happened because of this function.
Yeah, equation.
Equation. It's a function. Function f
Yeah.
of x is 2x plus 5. So we have passed this
Yes.
vector through this and we got this answer. Correct.
Mm.
This is, so basically all the computer engineers, information science engineers, computer scientists, all of them have been working on.
Hello.
Yes, yes, yes. I'm there. All this time, what you think was the computer scientists doing? They were working on this aspect. How to get, how to compute this pink color and get this yellow as the output. So you work on the pink and get the yellow as the output. That's what computer scientists, computer engineers, and your information, I guess, no, information science. All the BTechs, information science, MTech information, all these people are. So how many, what are the activities here? The different cases. One, see, this aspect here, this could be on cloud. This needs to be secured. This needs to be put on database. And again, this whole function can be on cloud. This function is the real formula, right? Very important formula which company has devised. So it has to be secured. It has to be parallelized, because suppose this function is used by tens of thousands of people to compute this, suppose on cloud. So this has to be parallelized. So this is what has been happening in the world of computer engineering so far. You getting the point? Is it making a little sense?
Yes, sir.
So for this you need databases, websites, cloud computing, information security, cyber security. All of this is a part of computer science itself. Now we change this. In machine learning and AI, these things will change. And machine learning and AI, both of these are known, and this is not known and needs to be computed. So in machine learning and AI, what happens? We give a data set where we say 2, 5, 6, 9, 15, 17. We already know. We know that 2 has become 9, 5 has become 15, 6 has become 17. I want to know how. Can you learn this? Is what we are asking the machine. All problems are this only.
Yes,
Every
sir.
machine learning problem is this itself. There is nothing which is different. And why I would be so confident in saying all machine learning problems are this only? Because the human brain, if you think about it, can only do two things. One is feel, other one is count, third one is decide. Feeling, counting, decision. That's all the machine can do, or the human brain is capable of doing. Feel came evolved first. Feel, this is a slow evolution. Evolution also happened in this way only. When we first evolved, we were only feeling. That feeling became, we were expressing that feeling in terms of sound. Slowly, the sound became symbols. Those symbols became language. But slowly we evolved and we started putting a count to the sound. So we now are able to calculate, get the context of time, time based calculation. Then we have intelligent communication. Once we have all these things, we will use this counting and feeling to get our
Decision.
calculated decision. That's how the human brain works. So when the computer was created, when the computer was created, we basically divided the data types, the fundamental data types in a computer, we divided it into character, integer, and boolean. Character is for a categorical data, integer is for numerical data, and boolean is for logical decision. Making sense a little?
Yes, sir.
Now, going a little deeper, if I want the machines to reverse learn this, I'll have to define the types of machine learning based on what is the output that I'm expecting. So I'll let you know. Okay, so this leads us to understanding. So we understood that this is machine learning in AI, where
So, what do you mean by reverse learning?
reverse fitting. Reverse learning is by looking at input and output, you learn the function.
Okay, okay.
It is not learning how to compute this and get this. It is learning the pattern here and it is restructuring the function which gave this pattern.
Yeah.
So if I have to reverse engineer it, I'll have to clearly define types of machine learning should I say types of machine learning problems, not algorithms. Okay, types of machine learning problems. There are three kinds of machine learning algorithms and two kinds of machine learning problems. So basically, now contrast this with what your mind can do. So all our language, numbers, everything is based on field count and decide only. So type of machine learning problems are also based on this itself. One is called regression and other one is called classification. Any learning that we want the machine to do will either be a regression problem or a classification problem. Only two types. What is regression? Regression is if you are trying to build a function where the independent factor is also integer and dependent value is also an integer. For example, what we did with those numbers 2, 5, 6 became 9, 15, 17. This is also int. This is also int. So now this becomes a regression problem saying next time if the number is 8, what should be the answer? It has learned now because it has found out that the relationship was 2x plus 5. Now for any new number, it is able to predict this. Wherein while getting the machine to learn this, you are doing int versus int. So that's regression. Classification is dependent is always a category or a symbol. This is also category or a symbol. But this can be category and this can be int or a number. So sometimes you will use integers and make the machine say that look at all this integer string and I have categories which are there. Like for example, see the input and output, how it will be for a cat int versus category. How you will say 28 F, 37 P, 31 F, 42 P. What do you think I'm doing here?
Classifying into two categories.
Yes, and that is what? Pass or fail, correct? Marks. Above
Hmm.
35, it is pass. It will learn that everything above 35 is a pass. It will eventually learn this by building a function like this. Now category and category, an example of that would be say let's suppose class A. If the symbol is A, then their salary bracket is tier 1. If the symbol is B, their salary bracket is tier 2. If the symbol is C, their salary bracket is tier 3. Again, if it is A, it is tier 1. So this category to category learning is very easy because categories are few in numbers. Although how much ever data you collect will few in numbers. But when you do a category versus category, this regression line won't happen. Now it's a separation, a vector which separates between both. Because this whole thing is very simple now. You have categories here A, B, C. You have categories here 1, 2, 3. So every time A comes up, you will see all the clustering here only. Every time B comes up, you will see all the clustering here only. Every time C comes up, you will see all the clustering here only. So now it is, how are you going to divide this? So it will look at the data because it's a three-dimensional data. You have to see it as a three-dimensional data. All these values will. So then you will either use a support vector machine or a decision tree, which is not like a function which you have seen here. or a support vector machine. So the classifying between a category and category becomes a little different. You have to understand this. That's it. These are the only three problems. There's no other problem in entire machine learning.
So this is classification in 3D vector space that has to
Uh,
clustering.
the clustering has happened and you have already found the classes. The data
Mhm.
just gets clustered over there. That's what I'm saying. We are not
Yes.
doing any unsupervised learning yet. The
Okay.
data just gets clustered because when you plot the data, how else would it look?
Yeah. Yeah.
All the A will be there only, right?
Yes.
So if this is the way it is looking, then there is no point of you drawing a regression line. The regression line won't be able to. So either you will have to do something like, eventually you will end up doing something like this. If you're going to go for a logistic regression, a very complicated one. The function
Mhm.
will say when it function moves here, then it, okay, this is, because it's able to give you this value. Otherwise it's just flat. It gives you value, gives you value. So it clearly knows for this is a sector. For this is a sector. For this is a sector. It clearly knows when to give you what. So when something like this comes up, it will put 1. When something in B sector comes up, it will put 2. When something in C sector comes up, it will put 3. So basically that's how it is going to different. This, this, this. So it will be pointing to 1, pointing to 2, pointing to 3. Baki, it's pointing to none. So these are the main segments which is right. So this function wise, mathematical function wise, I'm expressing it. And when it comes to regression, what you're seeing, when it comes to regression, you will see something like this: a regression line,
Yeah. The best fit
the
line.
best fit line. Okay, making sense for others. Viresh, are you facing some connectivity issues?
No, no, I'm good.
So again, machine learns like this, not like this, like this. Earlier, this was the prime problem of all computer science people. Basically, you can get 256 into 2x plus 5 in many ways, in C programming, in C++, in Python, in Java. Same thing. For different reasons, different languages used, but same thing. Now, you give this, and the machine has to figure this one out. So far, you've understood this is the classical machine learning problem, types of machine learning problems. The same machine learning can happen, or the types of machine learning problems are done. Now, let's go and look at types of machine learning algorithms, which are supervised and
Unsupervised.
unsupervised learning, supervised learning, reinforcement learning. Under supervised, what happens? Okay, under supervised learning, there is this and there is this, and we clearly have the mapping. Because this becomes this becomes this becomes this is what you are telling the machine, so you're supervising it.
Yeah, like both are labeled, I think.
Both are labeled, but labeled both are labeled in the sense labeled as what?
Labeled as input and output.
Correct. One is feature vector, other one is
Output.
target vector. You use
Target.
these words, okay?
Okay, okay.
Okay, this is a technical word. Feature vectors and target vectors.
Target vector.
Feature
Yeah.
vectors can be many. Target vector is either one. It's only one. You have to join at this target vector. Next, unsupervised. What happens? You just have but no arrows, no idea of what are the feature vector nor target vector. It happens sometimes. Here, it is a step by step learning
Trial and error.
by, yeah, you can say trial and
Error.
error. Example, making a baby
Walk.
into a, yeah, making a baby, if you want that example. No, making a baby walk is different. Teaching manners to young kids.
Yes.
Reward good
Penalties.
behavior,
Punishment.
punish bad behavior. So basically, this is supervised learning. So in contrast, with respect to this and this, in contrast, what we say is that machines can solve two kinds of problems in three ways. Is the mapping okay? Two kinds of problems in three ways. Is this clear?
Yes, sir.
That's all there is to all. Then there is in between some semi-supervised and all that. You don't have to. Then people will create a lot, many versions of this. That is fine. That is just implementation version. Nobody cares whether it's semi-supervised. Basically, one is supervised, one is unsupervised, one is reinforcement learning. That's it. Now, so far, is it making sense? Now, I'll. What you want me to do? You want me to take a picture of this and send it to you? How would you like to make notes of this?
So in the end of the class, you can send us the PDF of this thing. It will be
The
helpful.
problem with this kind of notebook is it cannot get converted into a PDF. If it
Oh.
gets because it's not following a simple layout, no, say I'm doing
Yeah,
this,
yeah.
I'm
Mhm.
writing like this, it won't resolve, it will just gibberish it off. So the best thing I can do is I can just snip it off from here only and send it to you so that you can i'll just I'll just snip and send it to you later, all
Okay.
this separate parts. Okay, one
Okay,
big
sir.
picture of this also I'll send, then I'll send this small part, then this small part, so that you know that the fundamental of machine learning is this. So tell me, what are all the different machine learning algorithms you've studied?
Simple linear
Linear
regression,
regression.
multilinear regression, polynomial regression.
Tell me in terms of, for regression, what have you studied? For classification, what have you studied? Linear regression, polynomial regression, multivariate regression, classification, most prominent,
Yes.
hmm. Decision tree,
Logistic regression, KNN.
KNN, yes. Naive
Naive
Bayes, yes, KNN, large,
support vector machine. Decision trees, random forest.
yes.
XGBoost.
You studied XGBoost?
Yeah, he taught.
This is very powerful.
Yes, sir.
This also, but for a particular, this also, if you know which when to use what. Hmm? Now, now let's understand clear difference between and for machine learning. 256 under 2x plus 5 became 9, 15, and 17. And this was the model. So when you give these two and the machine says 2x plus 5, this is the model. That is the ML model. Correct? If the machine learns this pattern and brings out 2x plus 5, isn't this the machine learning model?
Yes, sir.
Right. Agree, Ganashri? Viresh?
Yeah, I agree, sir.
Okay.
It's a multiplication of the same formulas.
Sorry?
It's a multiplication of the formulas. It's a mathematical way of machine learning.
No, no, no. Ah, 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 ah. Arithmetic way of machine learning. This is machine learning. What I'm saying is,
Yeah, it's a machine learning, but it was in the past, it was in a mathematical. The mathematical came into the computer language as a machine learning, if I'm wrong.
algebra. Rebuilding the algebra.
Mm.
Arithmetic is just 2 plus 10.
Mhm.
You're rebuilding the algebra here, not arithmetic. Arithmetic is used, yes, but arithmetic patterns are seen to bring the formula back. Okay, so reverse engineering the formula is, you understand, 2x plus 5 is the one. Look at this, 2 becomes 9, 5 becomes 15, 6 becomes 17. Okay, so if you plot this, 2, 4, 6, 8, 10, 2 becomes 2, 4, 6, 8, 10, 12,
Actually,
14.
it is the same thing. If we are given, the inputs and outputs, we just figure out how they are related. That is logical reasoning. So the same thing is done by, like the machine, in a graphical way, I think.
You can see, you can think of it as simple also, you can think of it as a very clever trick also. I just want to show you something. 2 becomes what?
9,
9. Okay. 5 becomes
15,
15,
6 becomes.
17.
17.
So there is some pattern here. Correct? It's increasing only, right?
Yeah.
So this one, it's just what we call as a local function approximator. So all machine learning models are nothing but, all machine learning algorithms are nothing but function approximators. You understand the new way of looking at it? If you understand this way, then you understand it forever. You don't have any doubt ever. Local function approximators. So all machine learning algorithms are nothing but, whether it is this or whether it is this, both are what?
Local function
Not local. Both are function
approximate.
approximators. Machine learning is local. Deep learning is universal. So you can apply deep learning on something which you solved using for machine learning also. You can apply deep learning for this. You can apply deep learning on this problem. But you cannot apply machine learning on problems which deep learning solves. For example, I'll give you another 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. This is a vector. The output are only 0 and 1. And relationship, when it was 0.1, it became 0. When it was 0.2, it became 0. When it became 0.3, it became 0. When it was 0.4, it became 1. When it is 0.5, it became 1. When it's 0.6, it becomes 1. Again, when it was 0.7, it again became 0. When it was 0.8, it became 0. When it's 0.9, it became 0. Now, what would you call this?
It's an universal, but I did not get a 4.5, 0.4, then 0.5 and 0.6 is called as a 1, and rest are called as 0. Do we have any arithmetical things that we need to understand behind this?
Yes, the context. You are asking for why 0.1 will become 0 is you are asking, correct?
Yes, so 0.4 and 0.5 and 0.6 is 1, and the rest all are 0.
So this is, I'm saying this happened in the real world. I'm saying in my real world problem, 0.1 yielded me 1, 0. 0.2 yielded me 0. 0.3 yielded me 0. When I put 0.4, yeah, I'm getting 1. So basically, I'm asking what kind of function?
Yeah, it must be non-linear
Yes,
in 2D space.
yes.
It may be continuous or non-continuous function.
Yeah, if it is non-continuous, then you'll have to stitch it, or we have to do small extrapolation. But then so basically the non-linear nature is what I'm trying to understand. This problem, where it came from, comes from. Let me show. This is the problem. This problem comes from this problem statement, which is green, blue, pink are all three different groups of people. Group 1 gets a low dosage. All three groups have fever. Example, all three groups have fever. Group 1 is given Dolo 250. Group 2 is given Dolo 450. Group 5 is given Dolo 650. Dolo 250, 450 and 650 are paracetamols. For those who got Dolo 250, all these people, the fever did not go away. The fever just persisted. For those who medicated with Dolo 450, their fever went away. Now when the group with the pink, which got high dosage, Dolo 650, you're expecting the fever to go away. But what happened? Fever did not go away. This is something which happens in real life. Okay, not everything is linearly related. Sometimes some things are connected in a different dimension. It's not obvious to us. We are looking at it in a different lens, thinking the relationship is linear, but in some other way it is connected, and we have to now approximate the non-linearity of that relationship. Approximating linear relationship is much easier, but approximating non-linear relationships, they become challenging. So the equation for this, which function, I told you, right? Which function gives you this? Where is the function? Just now I want you guys to calculate for each and tell me. Okay, we have done this by hand. You will also do it by hand. Okay, take this equation. You see, y is equal to log of 1 plus e raised to minus d into minus 34.4 into 2 plus 1.2.14 plus log of 1 plus e raised to minus d into plus minus 0.5. You copy this equation, and to this equation you put all these dosages. So d, instead of d, put 0.1, 0.2, 0.3, check what happens. Do that quickly and let me know whether what we said is right or wrong. Will you do it now? You're used to y is equal to mx plus c, correct?
Yes.
You've not seen this is what the machine has learned.
Achha.
When you gave this as the input and output, you asked what kind of function will take 0.1, 0.2, 0.3 and get me 0. Again you put 0.4, 0.5, 0.6, it gives me 1. Again you put 0.7, 0.8, 0.9, it gives me again 0. What kind of function is that? Can you learn, is what you asked. And it says, okay, fine, you've learnt it and this is the function. Now go and check this. I want you guys to actually calculate everything and check this. I'll give you 5 minutes for this. Okay? You understand what I'm trying to say, Viresh?
Yeah, I got it.
Yeah. Just do a
The
calculation.
behind output that we need to calculate the arithmetical
Yes.
loss.
Yes. Put 0.1 to 0.9 and tell me what happens.
Oh.
Were you able to compute the first few?
The first one it make it 8.64 cell when it's 0.4.
Anyone wants to say something? Over 10 minutes has been given. Did you check this?
So I'm trying to compute it, but yeah, behind the scenes, I'm just like classifying the input into two, like a signum function. That's what I'm doing.
What?
You asked me to like calculate the values of y
Yeah,
for.
just put instead of the d, you put 0.1 first.
Okay, okay, I'm doing it.
So what happens when you put
So
0.1 for d?
0.1, it's become 8.64, sir.
So e raised to minus 8.64, correct?
Yes, sir.
So what is e raised to minus 8.64?
Is it-
That is 1 by e raised to
E raised to.
I'm not sure.
8.64. So all you have to do is e raised to 8.64. So in a scientific calculator, you just x square is there, no? Okay. The value of e raised to 8.64 is approximately 5640.06.
Okay.
1 divided by 5640.06. 0.0001. So you get 0.0001. This plus 1 is 1.0001. So find out what is log of 1.00071. It is 0.0030. So you have here 0.0030. Now calculate the same thing for this. Minus 2.52 into this is into 1.29.
So that is into or plus.
Into sorry. Oh, sorry, yaar, it is plus. Both are plus.
Yeah.
My correct. My bad. Now we have to recalculate this. Sorry for that. Let me also quickly get that computation. Minus
So,
34.4
so the
into,
zero is sorry. The negative is upon the multiplication of three expressions, right?
yes, first we have to add this.
Add what?
Minus 34.4 plus 2.14.
You said multiply, sir.
This is addition.
Okay.
This is multiplication. This is, you see, this is a small y is equal to mx plus c. Are you seeing this? Mx plus c. Mx plus c. M into x plus c, right? You see this? Small mx plus c is here.
To the e power, right?
Yeah, e raised to, then we'll do e raised to. First we do this. Minus 34.4 plus,
So then the value will be like 1.54, the first equation. The second equation will be 0.49. If you calculate both the logs, it will become 2.031.
okay, let me check. Minus 3.2 e raised to 3. 0.03. 0.01. This I'm getting.
For the term ones,
Yeah.
I got 1.54.
See, when you do 32.4 plus 2.14, you get
So
32
there,
point something, correct?
there is 32 or 36. First
Which one?
First one is 34.4.
34.4
Ah,
plus 2.14.
okay.
so let me break this down then. So you tell me, all of you, let's just put this here and let's break it down. Minus 34.4 plus 2.14. What is it?
Sir, I'm not understanding how you are
But
doing it.
Minus 34.4 plus 2.14.
No, no, you have said it is in mx plus c form, right? So you must multiply d and 34.4 first.
Okay, yes, yes, yes. Board mass.
Yeah, you can't add that.
Division, multiplication, addition, subtraction. Yes, first do multiplication. Correct. Hmm. Regardless of whether in which form it is, board mass. Correct, 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 Gigi. Good observation. Thank you for that. Right. Let's do this. 0. D becomes what? D is zero point
it's
0.1 first.
0.1.
Ah,
Remove the negatives, sir, from both expression. It should be positive after multiplication.
okay. So D is 0.1. So you have minus 0.1 into minus 34.4 plus 2.14. What is this? This is when you remove negative, it becomes one shift, so it is 3.44 plus 2.14. 4414 becomes 58. This is 5.58. So your equation now gets reduced to you have log of 1 plus e raised to 5.58. Correct? Are you all till here?
Yes.
Confirm once. E raised to 5.58. E raised to 5.58. I'll get the or something must be 259.74. This is log of 1 plus 259 is almost equal to log of 260. Now go and check what the log 260 2.41.
Six point. I've calculated, sir. I think 6.73 for 0.1.
Full calculation.
Yeah. Y value.
So when you see, this is e raised to minus of this expression. So if you multiply minus into this, what happens? Maybe somewhere that's what the mistake is. Minus d into minus 34.5. It's like this.
So y value must be integer, right? Like according to the problem, one
It
or
should be
zero.
either 0 or 1. Almost 0, almost 1.
Acha.
Let's try to do this. Minus, this is so given. If you multiply this, it will become minus 0.1, or I can internally get this done and then multiply it by that also. That will be the same. So 34.4 into 0.1. Let me just do it clearly once, because otherwise I myself will do 34.4 into 0.4. 33.4 minus 3.4 plus 3.4. So this is 3.44 minus 2.14. Okay, which is minus 2.14, 1.3. This becomes 1.3. So now I have to do e raised to minus 3.66. This
Sir, please, if it is the correct equation as you mentioned,
yeah.
is it?
Why? What happened?
No, I mean the values are in decimal form, not in the integer. Maybe it is not even near to 0 or 1.
How you? I got 0.669. You also got the same?
Yeah, I got 6.61, I think.
No, the first value I got 0.669.
Okay, okay.
Usually nobody does this by hand. Okay, nobody who's teaching today deep learning or anything,
Yes, sir.
nobody does this. But we cannot be everybody, no. So I'm convinced you can. If you guys see, let me clearly see. Gigi and Viresh and Ganesh, see this. D I was putting 0.1. Now I get that it is e raised to minus d into minus 34.4 plus 2.14. If you want clarification, it is here. This is what has happened here. See,
Okay.
dosage. This
0.5
is the
into
deep learning. 0.5. This is 0.5. That is d into minus 34.4 plus 2.14. Log of 1 plus e raised to this factor. Almost very small. So when you put this value, it just comes up to that. So first, whatever the dosage gets multiplied by this. Then it gets added by this. Then that value is taken here. Then that value is again multiplied by
by the sum of the
this
total of
number.
log 1 and log 2.
So this multiplication and then sum of this. So this I have missed, correct? this multiplication into minus 1.30. Correct. All right. Y is equal to log of 5 plus e raised to minus b into minus 34.4 plus 2.14 into minus 1.30. Correct? No, no, no.
Yes, as per the diagram, Apo.
As per the diagram, this is not this into this whole thing log of this. This is the whole thing. This into minus 1.30.
3.
Okay, so this plus log of.
Sorry, sir. Like suddenly power cut happened and
Okay, okay,
I
okay.
had problem with Wi-Fi.
No issues, no issues. Okay. Minus p into
0.66 is value of first expression, right?
no, no, no. I have not got it. I am recalculating it because I made a mistake there. You saw that now.
So according to that, then it will be 1.26 whole value. Y.
1.37, I think, GG. I mean, point 0.3 something will see.
Once again,
I'm rewriting the equation, guys. I made a mistake there. I
I
forgot.
got to sir. We added those things, sir.
When
Wow, minus 1.30, which have been added right
one
now,
more
sir.
is there now.
Oh,
See this here.
okay.
For second one into 2.28 is there, right?
Okay.
So because 0.669 into minus 1.30 was supposed to be done. Zero until 0.669 it is correct. Here for the first expression. 0.669 into 1.30 minus 8.697. This whole thing into minus 0.6. This is minus 0.6. Similarly, take d into d was 0.1, correct? Okay. 0.1 into 2.52. 0.252, that is minus 0.252, which becomes 0.252 plus, no, so this gets reduced to log 1 plus e raised to 0 0.1 minus 2.2 plus 1 is equal to 1 plus e raised to minus 0.252 plus 1. This gets reduced to 1 plus e raised to 0.252 minus 1. This gets reduced to 1 plus e raised to
So can you explain the second line? Log of 113. What is that?
log of 1 plus e raised to minus.
No, no, the second line. 1 plus e power 1.3. The second line, sir. Not here. Not here. Above. Not here. No, no, not here, sir. The first one where you calculated 0.66.
Okay.
Here, log of 1 plus e power 1.3 goes to like what is?
This one, huh?
Yeah, is it a value of 1 plus?
Log e raised to 1.3 became 3.669.
Okay,
So log of 1 plus 3.669 is equal to log of 4.669, which is nothing but
okay.
0.669 into minus 1.30 because this minus 1.3 was missing. So I got minus 0.8697
So why did you multiply with minus 1.30?
because this was what was computed by the deep learning algorithm. You see this?
Efficiency, yeah.
No, 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 not efficacy. This one.
GT
Dosage
at the top
into
after the algorithm we have now star minus 1.0 in the bluish color on the top. If you see that before the sum plus minus 0.5 have added, it
Yeah.
was missed before in the in the formula. Sir has added now as an into minus 1.30.
for the first expression. For the second expression, into
It's
2.28
2.8.
also has been added. Anyway, so can I do this? 0.252 minus 1.29 minus 1.038. So it is e raised to 1 plus e raised to minus 1.038. Now e raised to, this is nothing but e raised to 1.038. Okay, let me directly calculate. Is minus 1.038.
0.35. Minus 1.8.
Minus 1.038. That is
Yeah.
0.341.
3541
0.3541. Now I need to do
plus
right. Log of 1 plus what it came up to 0.41.
0.3541.
So I'm ending up with log of 1.3541. Correct?
Yes, sir.
The log of 1.3541 is
0.1.
0.1.
131. Yeah.
0.13. This into 2.28, huh?
Yes, sir, 2.28 with the final expression for the log 2.
Which is
0.3001.
0.
0.3001. Yeah.
So this is done. This is done. So you have 0.8697 plus 0.3001 minus 0.58. How much is this?
Zero point 5898.
How much? 0.
5898.
98.
Then either I have done some mistake in calculation somewhere.
Sir, I have understood everything. So yeah, I need to like get clarity on that. You have multiplied 1.30 and 2.28.
Hmm.
Yeah, I didn't get it.
You understood this?
Yeah, remaining part I have understood. I think I missed hearing that. Why it is minus 1.30 and
No,
2.28.
but this also I did not explain on you. You understood this?
Which one?
This yd into minus 34.4 plus 2.14. I have not.
Yeah, this one. Please explain once again.
This one, no?
Yeah.
This I have not come to it only. I have to understand this. You have to come from here, from beginning. This is not. This is only giving. I'm just trying to explain to you that a non-linear functions model looks like this. That's all.
Mm-hmm.
How the model is developed, we
Actually,
still
it is
have
a
to.
combination of two functions.
Yes,
Yeah, yeah.
and not like y is equal to mx plus 3 kind of
No, no, no. I
manipulation.
understood. Like it is a combination of two equations with like
See,
separate domains.
basically, I have actually computed here. If you see, this also I have computed and then summed up here almost 0 plus 0. If I put 0.5 into this value, this is 0.5 dosage into this. See, I've summed it 0.5 into this 0.5 minus 2.52 plus this one computed here. Then log of that is computed here into 2.28 is computed here into this is only very small. Log of 1 plus e raised to minus 15 becomes so small that it when you multiply it by minus 1.30 it doesn't matter, it becomes small only, so it's almost 0. So this first factor almost 0 plus the second factor which is 0.71 plus 2.28 minus 0.58, 0.7871 into 2.28 minus 0. Almost this is 1.61 plus or 1.61 minus 0.58. So what is 1.61 minus 0.58? 1.03. So we said when the dosage is from 0.4 to 0.7, whether the fever went away, it went away, correct? 1.
Yeah, yeah,
So
yeah.
this equation holds good for 0.5.
Mm-hmm.
Maybe somewhere something I missed in calculation, but here it is quite apparent because I've already calculated it here. Exact to
We took
exact.
0.1. Yeah.
When we take 0.1, it is not giving us, correct?
Yes.
But for 0.5, it is giving us. So I'll figure this out. You also take this picture only if you want, this picture itself, and this picture we can calculate the first, calculate the second, and then add it up, whatever you get, sum it up, and then you'll get it. So finally, yeah, we'll be able to see that this is the equation when we give a non-linear relationship. Now we have to figure out how did the machine figure this one out.
The questions, right?
Yes, these weights, these are called weights.
Yeah, wait.
So it's like a mini mx plus c is what I was trying to tell you. Mx plus c, mx plus c. But what is this now? Log of e raised to, why you brought this logarithmic functions over here? That is the nature of non-linearity, because you need a non-linear element to anyway, let me not get there. I just wanted to show you, my intention was what, my intention was to make it clear to you people that you have seen y is equal to mx plus c, yes, but all, even though it is a complex non-linear function, it is still a algebraic relationship only that you're seeing. That's what I wanted to show you, which is here. This is what I wanted to show you. So let me just for the sake of clarity, let me just somehow we need to figure this one out. It has to come. If it is coming up very well for 5 and 6 and 7, I will write a function only for this, correct? Can you guys do that as a Python exercise?
Sir?
Can you guys do that as a Python exercise?
Yeah, like figuring out the equation, right?
No, wait, let me see if I can put this into. Do you think I can do that?
I don't think it can recognize handwritten equation.
It can, yeah.
The braces and everything.
Yeah.
Sir, in chat box, I already dumped the equation.
Correct equation you've done.
Yeah.
Then that equation only we'll give and ask it to compute, no? Where's that?
GG, in that equation you have missed out like
Like the multiple
yeah,
things.
yeah, last multiplication value.
I'm updating it.
Anyway, it's okay. I didn't want everything to be very abstract and just superficial, so I just wanted to make sure that you guys understand. Oh, no, anyway, Gigi, I
Yes.
don't need the equation. Okay, you put this equation into a Python function
Okay.
and run it from 0.1 to 0.9 and see the results. That's all.
Okay. Okay.
Will you show it to me tomorrow? Or Ganesh, you can also do it. This is a good Python exercise to do.
Yeah. 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 Evening,
Okay.
I'll send you.
Yeah.
Yes, yes.
So you
In
can
format
just
of CSV, I'll send the results.
no no no. You just confirm. Just confirm. That's all. I don't want the result. If you
Okay,
write the
sir.
Python function, then just share that function to others. Let them also confirm. Don't give them the answer.
Okay. Okay.
Okay. You write the Python function. What you will do? You will send an array of 0.1, 0.2, 0.3 till 0.9.
9.
And for
9.
every value, you check whether it's 000 came, 111 came, 000 came or not.
Okay.
Okay, sir.
That's all. Okay. It's a good exercise to do. But anyway, coming back to the real thing, there is so much else, so much more to learn here. So much more to learn because the clear ML knowledge is the one which paves fine foundation for your deep learning. That's what I wanted to make sure that you are getting. So let me again go back to our
So once again, please show the weights, sir. What first one is minus 1.28,
you
and the
take a
second one
picture
is
of this. Wait, I'll show you.
yeah, screenshot. I'll take it.
Yeah. This is a hand calculated one. No, it may not be perfect. It may be around that value, but you take a picture of this.
Minus 1330.
No, no, take picture. Shall I send you the picture?
Yeah,
Take a
yeah.
snip
Please
and
send
send
it.
you the picture. I'll send the picture to the group. Got the picture now in the group?
Yes, yes, sir.
Now let's get back to. So we are still here. Now you got a glimpse of that deep learning model, correct?
Yes.
You understood the difference in between machine learning and deep learning.
Yeah, in the machine learning, as I observed, it is like more dependent on human regarding to the questions and everything. Here it is figuring out by itself.
How it will depend on human?
Like we are defining how many questions or something, you know.
Where? How many in machine learning? How you will define how many questions? Where is that definition?
So when we go to simple linear regression, we give only one. When it is, you know, more than
I'm showing the simple linear regression. See this. This is a model kit which is getting built, correct?
Yeah.
Seeing the cursor, this is a model which is getting built. This model started from so far. This is the story: experience, salary. The data set is scattered. It has a pattern. Next comes a. In fact, it's a good that you asked. Good that you asked this. This is a great place to start this from. What is this line? What is this line that was drawn?
Maybe
The symbol of the
classi-
tier 1 or tier 2 or tier 3 is
classification of two groups. When the equation is less than 0 and greater than 0, something like that.
No. This is a regression problem. No, I'm asked it to do a regression.
Acha. Okay. Got it.
It
Like,
starts with this line. What is
yeah,
this line?
it starts with this line and with changes in quotients and constant in the
Correct.
line, it will fit the line.
So
Fit the
what
line.
is this line then? When the first line was drawn, what? So okay. Let me ask all of you again. Let me ask all of you. If suppose this line was not there, you are
Okay.
seeing this data points. Will
Yes.
you draw this as the model or this as the model? Yellow or pink?
Yellow.
I think yellow. Like
Yellow,
if there are
correct. You will obviously we will not start here. But the
Yeah.
machine is not looking at this data point like you are looking, no?
Yeah.
Yeah.
For the machine, what it is seeing, machine is seeing only a list of salary or a list of experience. It's not seeing, right? It is processing these two lists, correct?
Yeah.
So when a machine is trying to learn, always remember this is the truth, okay? It will take a this guess is called as just take some time to process this. Machines are trying to learn. Machine is trying to figure out how this number, how this 1 becomes 1 point, how this value 1.7 becomes 1.1, how this value 3.2 becomes some 1.8, how this value 6.8 becomes some 10.5. How is it? This connection. What function gives me that connection? That is what it is trying to figure out now. But in a machine way, you have to understand it. So I'm giving an abstract idea now, which is fundamentals for any machine learning, be it deep learning or your local machine learning. It will start with guess. But the good thing, it is also observing the reality. Both reality is being shown to it. It is seeing the reality. Based on the reality, it is taking a guess. Otherwise, why you would take a guess here? You could have taken a guess here, no? Understand what I'm trying to say? How did it figure that the guess has to be taken in between these lines? If it was not observing the reality, it would have taken the guess here. Then it would have taken longer for us to come here.
Yes. So the initial line is somewhere similar, like nearer to the original best fit line, right?
Can't say nearer.
Yeah, I
Once
mean,
initial line has been put there, the guess has been taken. There's a guess taken. With respect to what? With respect to
Reality.
reality. Now slowly you want to get your guess towards and eventually your guess becomes the. So all machine learning problem will do this only. Take a mathematical guess, understand the mathematical reality, mathematical aspect of the reality, then iterate over the guesses, fine tuning, so that finally you come to this R. Only in terms of regression, how do you do this? Guess minus reality is nothing but error, correct? So whatever was the reality, that minus your guess is the error, correct? Students,
Yes, sir.
are you understanding this or
Yeah,
you
yeah, yeah. Yes,
confused?
yes.
Yes, sir.
Viresh?
The distance between the original data point and the guessed, like the point on
Yes.
the line, is the error,
Correct, correct.
and we
Viresh,
are when minimizing that.
absolutely, Vijay. You get the whole point. Viresh, are you understanding this?
Yes, I'm understanding that.
Mathematically, we are now difference. This G minus R is nothing but this point minus the point here. This point minus the point here. This point minus the point here. So I am just summing up all this. Error sum up. So that is what it is called as mean squared error. I'm squaring this and adding them up and taking the average of it. I'm squaring this, adding them up, taking the average of it. So that becomes my mean squared, sorry, not MSR, mean squared error. Mean squared error. So let's go and check this. Always keep this progression what you're seeing now. This progression is what is finally you're coming here. At this time, at this point of time, you have minimum error. Okay. So with that minimum error, let's check this minimum error. So we are trying to change what? Trying to change the slope of this line so that the error between the guess and reality is decreasing step by step. And while it is moving, I'm calculating this C intercept value and the slope value, which is continuously being calculated. So once this is done, this is the final equation and that's your final model. Now the key thing to observe is, you see this step I'm taking from here to here. It stopped here, okay? It stops. It just stops here. It comes here, it moves, it stops. But observe one more thing here. Observe this, and this is where the whole magic happens. 1.8, 1.52. Next number, you see this, okay? This number you see 0.6. This 0.76 you see. Per value it is increasing. Every value it is computing slowly. So you have observed that the line is both shifting in C and moving in slope. How did we decide that the line, this angle of the line, should it move like this Or should it take big steps like this? Or should it take small steps like this? Or should it take some steps like this? What do you think of this pattern? You see this? You see the difference between this pattern and this pattern? Are you seeing this? What is the difference?
They are different of every point has a 1 point of difference, or like 1 centimeters in the scalar.
Here, no? Here
Yeah.
every point has equal. Here it is not equal, correct?
Yes, sir.
It is 4, 3, 2, 1. This is 4, 4, 4, 4. So which one do you think, how would you like learning to happen? Like this or like this? Which is more intelligent? Like first it
The
takes
first one is
First one.
first one is more intelligent? The right one or left one?
the left one. 3, 4,
2,
4,
1,
3,
correct.
2, 1.
So if the algorithm demonstrates intelligence, it will first go 4, then it will slow down, slow down, slow down, slow down, and converge at the exact slope and the c for which your error is minimum. With if you go like this, 4 plus 4 plus 4, you might shoot off the minimum. You might just shoot off the minimum. So you see what you're seeing here, this left wala equation, it looks like this. Have you seen this equation? This is the m value. This is the error. Or you can say mean squared error. So as the mean squared error is, as the m is increasing, your mean squared error is
decreasing.
But as the m increases further, what happens? The mean squared error again increases.
Increases.
So you have to find the optimum m, which is here, such that your mean squared error is the minimum. Whether it is linear regression, whether it is logistic regression, whether it is deep learning, whatever it is, this gradient descent algorithm is always at play. Always. Why? Why it is always at play? Because somebody is typing something. If you're typing something, mute and type. Are you writing that? Somebody is writing this down.
No, sir.
If you want to type, then please mute and type. Because I'm able to hear the typing. So why is it always guess? Why is this gradient descent always important? Because mean squared error is always there. Why mean squared error will always be there? Because what is that error? Error is nothing but guess minus reality. So any machine learning algorithm, whatever you give as the input, which is nothing but a pair of feature vectors and target vectors that you introduce to the algorithm, this is the reality. And the machine takes a guess on the reality and slowly does stuff to bring it closer and closer. This is a fundamental idea of a machine learning algorithm. There is no magic that happens here. It is just an arithmetic guess over an arithmetic form of the reality. Shall we take like 6 to 10 minutes break here? I'll also take a water break, and then we come back for the last session, last hour.
Sure, sir.
Okay, sir.
Okay, sir.
But be there, huh? In 10 minutes, 4:05 will start. Turning on the recording. All right. So, fine. I think you've given me one version of the Python code. Maybe we should check if the other
Yeah,
version.
we have no clarity on the equation. That's the problem. According to the picture we have did it, so we both got the same outputs.
But here in the picture that you have shown, it is 1 plus math or math dot expression, math dot exponential
Yes, sir.
of x.
Yes, sir. X is the expression.
Ah, that should be x should be 1 by.
Even if it is 1 by x, then the values are not matching to the picture.
No, I'll only calculate it and if that was the case, then how did we get this?
So did you assume as if it is close to 0 or something?
Yes, it has to be. I didn't assume. It is a calculated. 0.5 into minus 34.4 plus 2.14. How did this become minus 15.06? 0.5 into minus 34.4 plus 2.14. Sir, that is correct. Yes. Yes. Why not? 0.5. Minus 17.2. Minus 2.1. 15.06 minus 15.6. That's correct. This expression is correct. So instead of that, if I do 0.1 into 34.4, 3.44, which is minus 3.44, minus 2.14, 1.3, correct. It is minus 1.3. 1.3. Log of 1 plus e raised to 1.3. This whole thing became 1.3. I don't want to, but I'm not able to move forward without getting a clarity on this. 0.1 into minus 34. Minus 1.3. So log of 1 plus e raised to minus 1.3.
Hello.
Yes, yes, I'm here.
So yeah, in the picture I've got 1.03, right? I have sent you the picture. For 0.5, I got 1.03.
No, I'm calculating for 0.1.
Acha.
You got 1.03, yeah?
Yeah, in the
For
code,
0.1.
1.03. Yeah.
Zero point 0.61. So for 0.1, I'm getting 0.61. I'll write this whole code properly and send you this one. You can recheck it later. Okay? I'll write this. This minus thing is getting confused. But this equation is right. For 0.5, you clearly saw it is coming up for this. For anything below, for 0.1, it is coming to below 1. Fine. So let's just we understood it, but you understood what you're supposed to get, correct? You understood what you're supposed to get. For this one, I got 0.61. For 0.1, I'm getting 0.61 here. For 0.5, I'm getting 1.03 here. We now have to calculate for 0.8 once and see what happens. So anything below 1 will be taken as 0. Anything above 1 will be taken as 1. Its efficacy wise. Above 1 it is 1. Below 1 it is 0. So that's how it is getting calculated. Let's check for 0.8 also. I'll show you here. I'll show you what I'm doing here so that nobody gets confused. 0.8 into 34.4 is equal to 27.52. So it is minus 27.52.
Yes.
So I minus this by 2.14. So answer is minus 25.38. Okay?
Okay.
Minus 25.38 log of 1 plus e raised to minus 25.38. So I need e raised to minus 25.38. We go here, we raise it to
Minus 25 point.
25.38. Very, very less. You see this e raised to almost 0.
Yes, sir.
Almost 0. See this?
Yeah.
Okay. So if it is almost 0, so you're looking at log of 1, which is 0. Fine?
Yes, sir.
Yes, sir.
Now we come here. Again back to our calculator.
0.8 into
0.8 into, how much is this?
2.52.
2.52 is equal to minus 2.016, correct?
Yes.
Yes, sir.
Minus
Minus
2.016 plus,
plus.
so I'll do minus now.
Yeah.
Minus 1.29 is equal to minus 0.726, correct?
Yes, sir.
Minus 0.726 minus 0.726 is 0.5 almost, which is 0.5 for this. So I'm looking at log of 1.5. Am I?
Yes, sir. 1.48.
Log of 1.5. 1.76.
Hmm.
0.17, sorry. 0.17. Okay, 0.17. 0.17 into 2.28. Correct?
Yes.
0.176 into 2.28. 0.40,
128.
0.40128.
Minus 0.5.
0.128 minus 0.5 minus 0.58 minus 0.17. So 0 only, right? Correct?
Minus 0.1, yeah.
Minus 0.17. So for 0.1 below 0, for 0.8 below 0, for 0.5 around 0.5, 0.6, 0.7, you will get above 1. So both one value of those dosages, high, medium, low, medium, high, both are calculated. We're getting this. So we'll have to just refine that algorithm properly by giving 1 by x, and I will do that. I'll refine that algorithm properly and I'll give it. Meanwhile, you can also try, but in front of you, I've done the calculation in front of you only. There is no mistake. Okay. So it won't have, because that's an equation given by the system, no? So it won't have any mistake. So yeah, so that's what you're looking at. Now the question is, you have to learn how this was calculated. You see this multiplication, this addition, this. So basically, I'm saying, I just told the system for 0.1, I need to get value 0. For 0.2 also, I need to get value 0. For 0.3 also, I need to get value 0. For 0.4, I need to get 1. 5, I need to get 6, I need to get 1. For 7, I need to get 0 back. For 8, I need to get 0 back. For 9, I need to get 0 back. What should I do with this dosage so that what I want will come? And it says, do this with that dosage. Do this, all this. Multiplied by this, add by this take here. Multiply by this, add by this, take here, add these two, and then finally add this extra bias to it, and you will get your equation. If you do this, you get. So basically, how was this framed is the real deep learning problem. Are we clear about the problem?
Yes, sir.
First, clarity of what is the real problem is clear.
Yeah, finding the relation.
Yes, finding the relation as per the input output that we have given. And of
Yes.
course, this relationship was non-linear in nature, correct?
Yes, sir.
So sometimes we'll use log, sometimes we'll use something else. So first we'll have to go and see how these neural networks first of all work. So basically, a neural network is a network of artificial neurons which takes an input and sends out an output, but not for everything. It will not take an input and send out for output for all. It follows something like this. These 4 activation functions which are there, this activation function governs whether the output should be there or not. That activation function was here. This particular shape that you're looking at,
Sigmoid.
this is sigmoid. This shape, that is 1 by 1 plus e raised to minus x. Okay. This one which we used here was softmax. This one. That softmax function is soft plus function is log of 1 plus e raised to x. A sigmoid looks like e raised to x plus divided by e raised to x plus 1.
Plus.
A ReLU is like this. F of x is max of 0 comma x. Means if it is 0, if the input to this is 0, if x is 0, around 0, answer is 0. If x is slightly above max of 0 comma x means what? If x is equal to -2, what happens? Max of 0 and -2, what it will be? Response. What is maximum of 0 comma -2?
0.
0. So f of x will return 0. What if it is 0? What if you put, instead of x, you put 0.2? So it will be max of 0 comma 0.2. So what will be the answer?
0.
Max
0.2.
So that's what this is doing. So your functions, actually your activation functions, are the ones which govern the. So let's look at some activation function. Let's look at the sigmoid activation function. See, till here, for value -7, answer is 0 only. For -6, answer is still 0 only. For -5, answer is still 0 only. And as it increases, -4, answer comes here. For -3, it is raising. For -2, it is raising. For -1 and above, it has already come here, the response. That's it, it flattens out. After that, it is saturated. So it operates, it has a response only between -4 and 4 maximum. Only operation range is anything, any weights between -4 and 4, it will come here. Okay, this you remember, this is the nature of an activation function. It decides what range should get activated, under what range should the neuron get activated. And a neuron, whatever neuron that you see, or an artificial neuron that you see, it is only behaving, it is only responding to numbers. See the weights here. One weight, reality is giving back. Again, this guess is happening. So from this direction, comes forward propagation is the guess. Backward propagation is the weightage given to this guess. First it takes the guess saying, is this true? Then it says, no, you're so much right, you're so much wrong. The backward propagation is giving you how valuable or how close your guess is. So this keeps on happening to and fro until these weights are decided, for which the activation function is set. So once I select an activation function for a neural network, all the neurons will follow the same activation. This activation is a linear activator, which is of the form y is equal to mx plus c. This is a linear activator, or mx scaled. You also have something called tan h. So you want to see a tan h, it's slightly different. Like this, there are many activation functions. You don't have to think that these are the only ones, but these are the prominent ones for which learning happens. The tan h looks like this. Tan h e raised to x minus e raised to minus x by e raised to x plus e raised to minus x. Now for the same function that we did, here, if instead of soft plus, which is this, instead of this, if we had taken a ReLU was what? Max of 0 comma x, correct? That was ReLU, correct?
Yes, sir.
So instead of this, instead of taking log of 1 plus e raised to minus, instead of putting this here, we would have just taken max of 0 comma x. No calculating this. What is max of 0 and minus 15.06?
0.
0. So this becomes 0. Then what is max of that is 0 for 0. What is max of 0 and 0.3?
0.3.
Correct, 0.3. So here you have 0 plus 0.3 minus 0.58. So you decide, we decide here, this is our control. We decide whether we want our learning system to be activated for this activation function. Which activation function? ReLU, TANH, sigmoid. This is the neuron. Just hold this thought. You may, this just inside this, I'm telling you what's happening when you change this. But we'll now understand from the scratch what a neural network is and what it is behaving, what it is trying to do, by first playing a game between us. So first let me write here so that I complete this notes. Let me write ML or DL. Guess, the direction is guess to reality. Then comes second guess, one, second guess to reality. Third guess to reality. Fourth guess to reality. And fifth again guess. You do this until your guess becomes the
Reality.
So which now I'll write this. This is guess minus reality, and this is weights, or in linear regression M. So as the guess minus reality decreases, you are finding the optimal weight for minimum error, which is nothing but guess minus reality. This is called as gradient descent algorithm. This gradient descent algorithm is at the core of all machine learning and deep learning algorithms. All machine learning and deep learning algorithms follow this gradient descent algorithm. It's at the core. Now let's play a game. I have a number between 1 and 1000 in my mind. Can you guess it? Okay, all three of you. I have Gigi, I have Viresh, I have Ganesh. Please guess. I have a number between 1 and 1000. Can you guess? Ganesh, can you guess?
Sir.
Okay, Gigi, guess.
Okay, so 500.
Okay, Viresh?
Sorry, 100.
Ganesh?
70.
All wrong. Okay, guess again. Gigi, again, second guess.
750.
Viresh?
Sorry, 95.
Ganeshri?
123.
Oh, 120. Again wrong. Okay. Let's do this in a different way now. Now this time, we'll connect your guess with the reality. Okay. So we'll connect guess with what Vijay actually has in his mind, which Vijay knows, and it will give you a weightage for your guess. Now I have a new number in my mind. Now take a guess. Gigi.
Same, sir. 500.
500. And inside this, I'll give the weightage for it.
Yeah.
So I will give you a weightage of 0.01. Okay, Viresh, you take a guess now.
95, sir.
95. Zero point 83. Ganeshri.
900.
Second guess.
250, sir.
Sir, 100 for me.
100.
Yeah.
Ganeshri.
10.
So basically, if you can tell the guess is like less than or greater than the reality.
I'm giving you that only. See, from 95, he got 0.83. 83%.
Yes.
Oh,
For 100, he got 79%. So next time you should tell. So Ganeshri didn't know this. Ganeshri, otherwise, if Ganeshri knew this, she would not have guessed 900 at all, correct?
yes, sir.
Yeah. And you also, Gigi, you also missed it. Otherwise, here, second guess should not have been 25.
Yeah,
When
yeah,
I
yeah,
get
yeah.
95 is 83% right, you
Yes,
should
yes.
not have guessed this. Next, now you guess. Now you're all clever now. Now guess.
90.
No, Ganesh, your turn. You wait. Gigi's turn.
Okay.
Somewhere around 80.
Viresh.
75, sir.
Got it. Okay. So, because of these weights that I am giving, it is coming to you. Now you understand what that weight was?
Yes,
Yes.
sir.
These weights. Now you understood? But only in our case, it has to go run up and down many times because it's a very complex guesswork. It has to multiply by something, then add by something, and then take this factor and then add this. It's a very complex thing. Okay. But simple stuff you understood now. Now you see what happened when you are not connected with each other and you don't observe each other's weights, you'll keep on guessing randomly, correct?
Yes, sir.
If all your guess, these are all gamblers, you guys were gamblers now. If all you gamblers are connected to each other, or means what, listening to each other, then you listen from others and you see the others' weight and you take a very much more better guess, correct?
Absolutely.
So this is what your artificial neural network is. That's why it's a network of artificial neurons, and each artificial neuron is a gambler.
Yes, sir.
Who are going to gamble to bring the guess towards reality. So if you want, I can
reality.
contrast this. So I'm pretty sure you saw this happen right now, correct? Correct. We finally converged here. Converged here. Guess, guess, guess. Reality, reality, reality. This was the guess. This was the message from reality. This was the guess, message from reality. So eventually you converged at it. And Ganesh would also have said 75 only, no? Because she has seen 100%, right? So 75 guessed by her also. Eventually it's just a formality that comes up. Now let's go look at this perspective. Okay, now that we have like at 4:47, we have done close to about 2.5 hours of class. Has it been a burden or has it been a learning experience?
Yeah, it was an exercise for mind. It was nice.
Yes, sir.
Right? So you followed what I've been able to explain, correct?
Yes.
Yes, sir.
Shall we? It's okay. Can we extend? If are you hurry or you want to go somewhere? Can we extend like another, let's say 20 minutes, 30 minutes? Like I'll show you all this how it is going. It's a
Yes, sir.
very creative
Fine
and
for me.
visual experience.
Also, sir, it won't fine for me because I have explained you the situation in the call.
Half an hour more. You have to go somewhere.
Sorry. Yeah, I have told you in the call itself, no, sir.
Okay, after 5 you have to
Also,
go, right?
yeah.
Right, then give me 12 minutes as per this one. I'll explain it. How much
Okay.
I can do. Okay, fine. So let's see this problem. This is a simple problem in front of you. Right side, this problem. This problem. This problem has been shown to the neural network now. What is this problem? This problem says, look, all on this side are orange, all inside are blue. So we are asking the machine learning algorithm or deep learning algorithm, can you learn this pattern? So now let's understand what is the meaning of learning here. Meaning of learning is, what is this point actually? In terms of the reference that is in front of you, what is this point? This particular point, what is this? Ganeshri, tell me. You've seen this example before only. What is this point? Number, in terms of number. This is where 2 point something. So 2.2 comma, this is 4. So 2.2 comma 4 is orange. That's the data that you tell to the machine. So your machine gets 3 columns. One where it says 2.24 is orange. Next, 0.5 and minus 2. 0.5 and minus 2 is blue.
Blue.
Similarly, you take this 1.5 and 3.2. So 3.2 and 1.5 is orange. Like that, you have all these points data which has been given to you. Next time when I ask, suppose there is a point here, whose color I don't know. What is that point? Minus 2, minus 3.8. If I ask minus 2 and minus 3.8, what color should it be? You tell me, what color should it be?
It would be orange.
Orange. It is supposed to be orange. But can the machine also tell this? That's what we want the machine to learn. Okay. So let's see how the machine learns. Let's run this. It's going epoch. So what is epoch? What is this 153 epoch? Epoch is nothing but
Iterations. Huh?
Iterations, yes. How many times they have guessed and got the response from reality. So this is 153 times these gamblers have gambled and got response, but still there is no learning
Proper
clarity yet,
classification.
because this is not a linear problem. So we can't deal with linear activation. We have to go for something non-linear in nature. Let's run again. Finally it is able to say all this function, the function where this outer boundary is there, all are orange, and the function which is in the inner boundary, all are blue. For that it has given, it started with these two. Now what is this? What are these two?
That are the feature vectors.
The first two guesses, I think.
Yes. Not feature vectors. Vector is here only. The data is here. Feature vector, all these things which I told you, right?
Yes, sir.
And the target, it is here only. This was the guess taken by the network.
First two neurons guesses. Yeah.
Yes, first two neurons guesses. So which properties do you want to feed in? This is the guess taken by those properties. It says, this is saying, first guess is, first one guessed it as what? First one guessed it as everything on the left. The left 50% is orange, the right 50% is blue. That's the first guess. Second guess is the upper 50% is blue, the below 50% is orange. Now these four neurons here decided to listen to both and come up with its own guess.
Yes.
Then it is connected to this reality over here, and clearly it is getting some signals. So that signals weightages is here. All these orange ones are negative, all the blue ones are positive. So this is negative, positive, negative, positive. So the guesses are
The
here.
dotted lines, sir?
Weights.
Not that one, sir. The thin light dotted line.
This one.
Yeah. That was okay.
Also weight only. See, this one is listening to both. This one is listening to all four. This one is also listening to all four. So what happens if you increase the number of gamblers? Add another hidden layer. Add more gamblers over here. Earlier we had got the answer at 142 or something. Now let's see. Now 400 we had got at 480, 460 or something. Let's see what happens when I increase. Okay. So increasing the number of neurons is, there is no guarantee that you will get the answer fast.
Yeah, it may depend on activation function, everything.
It Depends on activation function for, but increasing number of neurons leads to overfitting.
Yeah.
So too many guesses, it confuses. One you could increase was, if you want to see a better learning here, what you can do instead is give some more opinions. I've highlighted this also now. So
Okay.
let's give some more opinions. See, 71. The
Yes.
base guesses were different. In 71 epochs only, you got a very nice. So
Yes,
this
sir.
this is called feature engineering. Given the data set, which features you want to build your relationship on. That is, which initial guesses you want to build a relationship on. You get a perfect, and that too in so much rate. Now let's go and look at this mega problem over here. This is not the problem. I've changed this problem now. I've changed it to this. Now let's run this. There's no way this gets solved. Okay. For this I need to add. For this I need more and more layers. And I need more opinions as well. And I now run this. But still there is no sign of anything learning. It's very complicated. See, from here to here it is like this. Then from inside this it is like this. It's very difficult for this kind of learning. So it doesn't work. So you change it to more modern activation function called rectified linear unit. It's called ReLU, rectified linear unit. So it converged, but it just went off again. So this regularization, let's go for L1. Let's increase the learning rate. Not happening. Nothing is happening. Something is better than it just went off because it learned too fast. Okay, almost there. So I want you people to go and This is wrong learning because this side it should not be blue. There's no meaning for it to be blue. And here it is some misclass calculation. But the idea is, I hope you're understanding that all of them, all these seven initial guess was listened to by this one particular neuron, and listening to all this, it came up with its own guess. Then it came up with its own guess. So whatever is white here, it's orange. Whatever is blue here is blue. Okay, the whitish. So you see, eventually, which one was getting? See, this one was getting good because it was looking like that. You see, so it gets a high weightage. See, yeah. But this one says everything on the side is blue and everything on the center is, so this gets a minus negative weight. All these guessworks are the ones which makes the whole thing click. This one is a negative weight. This one is a positive weight. Both of them are giving positive. Like it says, when I listen to you, I'm almost getting the reality. But when I listen to you, I'm not getting the reality. Now we have to understand in the next class what is this activation function, which you kind of already learned. What is this learning rate? We'll have to understand. What is this regularization? Regularization rate. You understand the problem type is classification. You understand ratio of training to test data is 0. Noise I have not introduced. Batch size per batch of computation is 10. If I increase the training ratio like this, then it will slow down because it has not enough to test. But input data is too much, but so you may get better model for training data. For testing, it's not too evident. In fact, if you really play around with this properly, see, this is very good, no? You see this? So nice it is, the learning. Excellent. But what about this? Why is this? Okay, it has projected this pattern to go down like this. But this pattern should have been orange then. Anyway, this is the best it can do because it's a very complex non-linear problem to solve. Very complex. Fine. So you'll have test laws, training laws, and all of this. You'll have to understand all of this in terms of mathematics. So some groundwork is required, which we will cover in the subsequent class to come. Cool. Shall we close for today? Right? Anyways, Wes, I'll just stop recording.